So let me just share my screen. Desktop 2, share. Okie dokie. Now, it went to show me that and it hid my participants. So let's get back to, here's my list of participants, but how about, oh, come on, show me stuff. Where did it put my people? Okay. There, that's not it. I don't win tab. That get me anything? That didn't get me anything. Huh. Okay. Some reason or other, I'm not seeing faces. You'd think the number of times I've used Zoom, I'd figure out by now how to work it. But
as we were talking about originally.
Exactly, yeah. So somehow I'm not seeing all the participants, but you're seeing my screen, right?
Yep. Your Fusion screen, yes.
Yeah, okay. If you're seeing my Fusion screen, then maybe I'll just get started and I'll not worry about the fact that I can't see you guys. Oh, more. Is there more here? Okay. So, well, first of all, let's talk about what a loft is. A loft basically is a way to blend surfaces or an object from one profile to another. Profile is an outline like typically we've sketched so far in the various different features. And so we'll use a loft to smoothly blend between different kinds of profiles. So in this case, let's start out with, start out with a simple circle down here on the base. And then we want to build a different profile at a different elevation. So what I like to do is start with the construction plane of some kind. In this case, I'll use an offset plane. And I'll offset it from here. And let's take it up 200 millimeters, say. And then let's sketch on that plane. And here we'll sketch a rectangle. So this is the very sort of one of the simpler forms of how we might go about this. So if we look, we have a circle on one plane, and then on a plane a distance away we have this rectangle, and we're going to create a blend in between them. So we can do this as a solid. First of all, if we do this as a solid, when we say loft, we get the option to select profiles. So we select our profiles in order. This is just 2 profiles. So it's pretty simple. And boom, there we go. We have this surface that goes from, or the outside surface, this object is circular at the base and rectangular at the top. It's a solid object. And So we can play with this. We can do different things. We can change dimensions, all the usual stuff, and it will update. So if we go to a sketch like this, and if we make changes there, it'll automatically update. And you can tell right from there that's an interesting surface. You can probably think of an interesting shape. You can probably think of ways that you could use that. But there's still a number of things we can do to manipulate this and get more control of this surface. So I'm going to say edit feature, and you'll notice up here, so profile 2, this is the top profile, and it tells us here which profile is which. And we can, in fact, change the order with the little pull down here. Now this is profile 1 at the top and profile 2 at the bottom. That becomes useful when you have multiple, like 3, 4, 5 profiles, and if you happen to get one in the wrong order, it'll break until you fix that, or make various changes, etc. So just a handy little ability to do that. But beside that, you'll see this connected. And right now, we have both of these profiles in connected mode, which means that Fusion 360 is going to do the simplest thing it can between these profiles. So in this case, it's a straight line. Now, there's a couple of things we can do to make this slightly different. One is we could say control it by direction. Now what it's doing is as the object begins from profile 1, we've told it to control the direction, and the default is 0 degrees. So it's taking off perpendicular from this surface. Now, if we want to, we can actually change that. So we can change that angle and affect it. So if we say 10 degrees, that causes a problem. It doesn't like that. If we were to say 1 degree, oh, sorry, that's takeoff weight, wrong place. That's why it broke on me. 10 degrees, you can see it fattens out, because now this surface, if we look at the front, these are starting off at 10 degrees, but then smoothly going back to the circle. Another thing we can do is there's something called takeoff weight. I'm going to go back to the default. There's something called takeoff weight here, and it basically controls how quickly the loft transitions from one profile to the other. So takeoff weight can go from basically, I think it's proportional. And we can make it more strongly influenced by the top profile or by the bottom profile. If I edit this, let's look at profile 2. Let's make it also direction. And if we change its takeoff weight, now it's going to start to drive the shape further along the profile. Okay, so now I said that there's different ways to create things. So this is a solid.
Tim, before you leave that,
yep.
When you do the takeoff weights, it just has units. Are those just scalars, or is there some sort of units that go with that?
That's scalar. It's not, it's unitless. And yeah, I'm not exactly sure what it means mathematically, to be honest. But it's kind of scalar. And if you're doing sort of free form, you can kind of play with the you can kind of play with them here and see what you get out of it, how you want it to be. Now that's on the positive side. Come on, it's not really giving me negative, is it? Let's try, oh, it's saying negative. Negative 20, positive 20. That's interesting. It's kind of the same in this case. Let's take this back to 0 degrees. Okay. Any other questions on that basic dialogue? You see rails and center lines. We'll get to those in a little bit. So this is a solid. We can do all kinds of things like we could do with solids any other time. You know, we can poke holes in them. We can shell it out. Etc. Okay, so just like any other solid, just that it's a complex shape. It's a little bit more of an advanced shape.
But Tim, instead of a circle and a rectangle, if you had 2 rectangles or 2 squares, would you end up with 4 planar sides then?
They could be planar or they could be curved. That's a good question, depending on how you define it. Let's get rid of this little demos that I put in to indicate that it's a solid. And let's go back to sketch 1 and edit this sketch. And what I'm going to do is I'm going to delete the circle and I'm going to make it a rectangle, but a different kind of rectangle. Whoops. I do that. Okay. And now it's broken. It didn't quite follow that. So let's just delete this. Why did it lose that? It somehow edit feature from here, distance 200, okay. Now, where's this? Oh, it's hidden. My sketches are hidden, that's why. Okay, so let's try this again. In this case, we'll do the loft from here to here. And you'll see that, as a matter of fact, they are planar if we do the simple connected blend. But if we force surfaces by direction, now we're going to get something that isn't necessarily planar. Does that make sense?
Yeah, it does. Thanks.
So yeah, it gives you a lot of freedom. There's a lot of freedom. And right now we're doing these profiles as parallel. They don't have to be parallel. And we'll get to that in a little bit.
So Tim, I don't, this is Rob. I'm not quite sure I understand the difference between I got connected and they seems like they draw straight lines, but what is this direction? What is that really telling them they're doing?
What what direction, sorry?
What is using the term direction versus connected? I mean, I see what it,
yeah, good question. That wasn't very clear. So basically, there are 6 different types of treatment or different constraints at the profile for the loft, depending on the type of feature that it is. So in the case where we're going from a normal sketched profile like this, we can choose to either just say a simple connection, the simplest connection possible. So it uses a straight line if it can, or the simplest curve it can, without any constraints about the angle of the surfaces as they leave the profile. So if we look at the side of this, you see this angle, this surface here, this side surface on my right, it's departing this profile at whatever angle takes it straight to the corresponding side on the next profile. What direction does is it allows me to control the direction that those surfaces leave, and therefore force a more complex surface, because maybe I need this to be perpendicular right at this point, or to have a specific angle. So direction says that I can specify the direction of the loft as it leaves that profile. Did I explain that in a way that makes sense for you?
Yes, I understand now what it's doing, and just trying to understand when I would pick which one, and maybe we'll get to that later.
Yeah, we'll get to some examples of that. Typically, if you're doing a very complex design, you might use multiple lofts, or you might have other features on top and bottom, and you want the transition at this profile to be smooth. So having control of the profile angle can help you to do that. That's one typical example. The other one is just the shape that you're trying to achieve.
So, for example, if you were using one where my audio seems to echo a little bit. Hopefully, it's not doing it to everybody else. If you were to do, like, you know, a dust connection where you have a set it's maybe an inch or 2 inches that are straight, and then you have a drop down for a couple inches so you don't get turbulent airflow, and then you go back to the lower side, you know, a reducer, etc. Would you do that with direction and multiple profiles, or?
Yeah, there's a couple of ways to do that, and we'll do something like that later on tonight, because that is a great example to show it with. Right now we're just doing 2 profiles, but you know, we can do multiple profiles. So let's say we let's create another offset plane. We're going to go from here, and we'll go up to 330, and then we'll sketch on this plane, and let's put a circle on this plane over here. Finish sketch. Now I'm going to move this sketch, this plane, and this sketch to be before the blend. So I'm rewriting history there. Now, so that when I edit the loft, sorry, I called it a blend. In some CAD packages, it's called a blend. Loft is a better term. Now I can add another profile here. Now when I do that, you see profile 2, I have no ability to control anymore, because it's not an edge profile. It's in between. But now look what's happened to my loft. it's forced it to go over and meet that circle. Now maybe I want that circle to be normal, and then maybe I'll extrude a circle on top of here so that I have a consistent cylindrical section, or I can taper it or what have you for the type of ducting we were talking about. Okay, so you can see that you can add a third or a fourth or a fifth profile. Now, before we get too much further with this profile, I do want to point out that lofts don't have to be solid. So
You can apply a shell to that. It's a pretty interesting profile.
yes, you certainly can apply a shell to it. So you can design it as a solid and then create a shell. Another thing you could do is you can go to surface and you can create this loft as a surface. And when you do that, it's very similar. Here's my 3 profiles. And again, on profile 3, I'm going to say direction. And there I go. There's my loft. But when I look at it, I can see inside there, that's just a shell. So it's a skin with 0 thickness, 0 mass. And I can do other surface modifications or add surface features to it. And then when I'm ready to turn it into something, I can always thicken it. So I'll thicken, I'll grab all these surfaces, and we make it 3 millimeters. Now let's make it 5 millimeters so we can see it a little better. And now it's a solid. This is effectively the same as making the solid one and doing a shell. So the obvious question is, when would you pick one? When would you pick the other? Surfaces, it depends the kind of functionality and the follow-on features that you want to do. Because surfaces give you a little bit more freedom to do certain things in some regards, and solids are simpler. So for example, that hole that I poked in the about 5 minutes ago, that's easier to do in a solid. So right now, this was the surface approach. Now there's something else. So any questions about solid versus surface here? There's another approach that we haven't really done much with yet, which is called form. And form is a little bit more, it's sort of intended to be more free form. So you can manipulate the surfaces. It's non-parametric. There's no history when you do it. It's direct modeling. This is typically used more in the sort of the artistic side. So if you're doing, my background in cell phone design, you would have industrial designers who are the artists, and they use tools like this to make a complex shape, and then they just export the surface model, and the engineers go and add the thickness of plastic and the structure, the electronics inside the antennas, all the detail. So in this case, we're going to go to form, and we're going to create our loft as a form. 1, 2, 3, and we're going to do direction on the third one. Now you see, it looks like a surface, but in this case, you see this sort of spider web on the surface. And that's essentially defining this model as a group of surfaces that we can then manipulate. And we can decide the density of these lines here. So we have spacing. We can either we can go either a uniform separation or space between each of these lines, or we can go by curvature. And if we go by curvature, then it will put more lines where the curvature is changing more and fewer where it's changing less. And or we can reduce the number of surfaces here. And I'm going to say OK and complete that feature. Now the obvious question is, this is a surface and we just did a surface, what's the difference? The difference is the tools that we can apply. So in this case, if we want to modify, there's a whole bunch of modification tools that we haven't looked at and we're not going to look at tonight. This is just a little preview. But you know, we could come in here, for example, we can grab a vertex and we can push and pull this thing. Now we've created an oddball surface irregularity in there. We can do that with any one of these vertices. So you can see it's not very controlled. There's no dimensions here. You might be able to use some dimensions in modification. I'm not even sure. I haven't done much with form, but it's more the sort of free form. It's kind of the analogy of getting the modeling clay in your hands and pushing and pulling it. So it's, in some CAD packages, they call it sculpting. Okay. Now, having done this, if we notice, this is one form feature. And when we right click on it, there's no edit. It's a non-parametric, non-editable feature. If I don't like what I just did, the only thing I can do is undo the edit. But I can't come back in and modify the change I made. I can make further changes. I can go move this same, if I'm in form mode. I can come and move this guy again in a different direction. But I don't edit what I had previously done. So can I transition from this form to solid? Yes, I can go back into, how do I get back to solid mode? I think I have to finish my form. Here we go, finish form, like sketch. Now I'm back in solid. I can create a thicken feature. I can grab these form surfaces. And now it's going to take a while to select them all. So maybe not the wisest move. There it is. But it's warning me that there's edge-face relationships. And this is one of the complications that comes with forms. So I'm going to scare you a little bit about forms. Sometimes the transitions aren't all captured. And so you need to actually patch them together. And I'm not really going to do that right now because it's kind of outside of the Loft feature. But effectively, you need to knit everything together before you can thicken it, because in this case, something we did, there's probably an opening in between one of these seams. Okay? But form something we haven't really covered yet. I just wanted to give you a little preview of it. and it's not something I use very much. I'm inclined to use solid whenever I can, and then surfaces when I need to. Partly that's just because I've mostly worked with solids. So back here, and we're going to do direction on this guy. And remember, these are since this is solid, this is all parametric and live, can be modified. But you know, some of this modification is a bit challenging to do. And we also talked about the fact that these profiles don't need to be parallel. So I'm going to show something a little different, but before I do that, I just want to check if anybody has any questions. Okay, so I'm going to delete this guy. And well, actually what I should do is just start a new drawing. I'm going to start a new drawing. I'm going to give it a name. So I'll save it as, and this is going to be vacuum adapter. Adapter, never exactly sure which one's correct. I think it's actually ER, but anyways. I'm going to change my units, in this case, to inches, since most of our vacuum equipment comes in inches. And let's create some parameters, some user parameters. I'm going to say large diameter, and that should be 2.5 inches for, say, a shop vac, and small diameter. Let's make this 1.5. I'm going to create one that says taper, and it's going to be in degrees. And let's give it, let's say, 0.5 degree of taper. And then what else? How about a wall thickness? Wall thickness, and let's go with 1/8 inch. Okay, so I'm ready to do sort of top-down design. It's not an assembly in this case. It's a single component, so I'm not necessarily needing to create a component, although, you know what, in case we change our mind down the road, or we bring in various accessories to fit to it. Let's create a component, and this is going to be, and just to confuse things, I'll spell adapter 2 different ways. Okay, so now we're ready to create a part. And let's say that, let's start a sketch, and we're going to come in from the XZ plane, and we're going to sketch a circle here, and this circle is going to be a large diameter, and that's good. Now, I want to create a fairly complex shape, and I want to guide this shape. So I'm going to create a different sketch. And this sketch I'm going to use to affect the shape of my design. So I'm going to sketch on this plane, and I'm going to use the fit spline. There's two different kinds of spline. We'll use a fit spline in this case. And I'm going to create a shape that's somewhat of an arc, but not exactly an arc. And I want to actually control it a little bit. So I will put some constraints. We haven't done a whole lot with splines. They're kind of fun, but let me show you a few things about splines. So splines is a way to make a smooth line, and you can have a lot more points in a spline and make them much more complex. This one's relatively simple, and they have handles, and with these handles, again, you can affect the shape. It's a little bit like that angle control we were doing before. And so in this case, I'm going to say I want this, I guess it's too far from the vertical. Let's try this again. I'm going to grab this and I'm going to say, make it vertical. And then I'm going to turn on my origin and see if it'll let me make an angle dimension between here and here. And yes, it will. So let's say I want to make that 120 degrees. Now, I can do things with this center point to change the shape within those constraints. Where, again, a little bit like the direction on the loft, we're defining the angle right at the end where it finishes. Now, we can actually also do that at any of the points. We can insert points. We can take points away. So we can modify this. This point, I'm going to just kind of go like this. And I'm going to finish this sketch. Now this sketch, when I look at my sketches, sometimes it gets confusing about which sketch is which. So what I like to do sometimes is name them. So you can actually rename these sketches. So sketch 2, I'm going to call the spine. Sometimes I'll put more features on this and call it a skeleton, but in this case, it's really just a spine. And this sketch I could rename if I wanted to as well, and I'll just call it large end. Now, I want to create a sketch out here at this end, but I don't have a plane there. There's a whole bunch of different ways that I can construct a construction plane, but the easiest one when I have this spine is I'm going to say a plane along a path. I'll select the path, and I'm going to say in proportional, I can go by distance or proportional, but at proportional, if I go to 1, that's at the very end. So in this case, it'll make it at the end of the path and perpendicular to the path at that point. Now I've created this construction plane. And I'm simply going to sketch on this construction plane. And I'm going to sketch a circle. And my circle is going to be the small diameter. And I'll finish sketch. Don't need to see this origin. Now I have two simple circles. And I can, of course, create a loft from this profile to this profile. And let's see what that looks like from, no, not that angle. Maybe from the front. And I'm going to make it perpendicular at both ends. Now, maybe I really want to have the thick part control it further. You notice that even though I created this spine, it's being driven by this takeoff weight and angle. So if I want to drive it by the spine, I have the ability to use rails to guide it along. So I'm going to add a rail, and I have two types, rails and center lines. This, you can tell from how we sketched it, is a center line. A rail touches the edge of the profile, it touches the profile. Each profile in the loft has to be touched by a regular rail. But the center line behaves like a center line. So we're going to grab this guy as a center line, and now it's going to follow that center line. Now the takeoff weight is really just influencing the thickness. And it's really not that happy about the takeoff weight. It's probably doing a lot of calculations to try and make that work. Probably something I shouldn't have tried. Yep. So in this case, I actually crashed Fusion 360. So while it's rebooting, any questions? One point that I didn't really make as I was going through there, that spine that I made, while it was curved, it was still flat in 2 dimensions. But we can actually create a spine in full 3D sketch spine, and the loft can extend in true 3D.
So I've got a question on that last form. You did direction and you wanted it to be perpendicular from the plane, and then you changed it to following the center line, which I would think took it back away from perpendicular to the plane.
Well, it would have, except that I sketched the center line to be perpendicular to the plane. So the first profile was sketched on that origin plane. And when I defined the spline, I defined that first point to be vertical in the sketch, which forced it also to be perpendicular.
Okay.
So the perpendicularity constraint, you're right, was no longer what was driving it. It was 2 different ways of achieving the same thing.
Thank you.
You're welcome. Okay, so actually, let's see. Did I save my vacuum adapter? I did, but I don't think, I don't want to try and bring back the autosave because it might just crash on me. So I'm going to create a new component, and we'll run through this fairly quickly. We're going to change the units. And we're going to add some parameters. Large D, 0.5. Small D, 1.5. Paper, degrees, 0.5. And wall thickness, 1/8. Okay. Now, let's start by, actually, before we do anything else, let's just save this. And then let's, oops. What's it waiting for? Tried to save it from within a sketch. Is that going to mess it up?
So we're waiting for Fusion to chew on this.
Yeah.
On the diameters, would you be picking the inner diameter or the outer? If you're doing like an adapter from a vacuum hose to a vacuum spigot, if you will.
Yeah, in this case, I was kind of just picking two different sizes of vacuum hose, like maybe maybe you have one hose, one device that has a hose that's one size, and
Yeah.
and something that else that has a hose that's a different size. So, for example, my shop's pretty basic and pretty small. I just use a shop vac as my dust collection.
Yeah.
I'm doing pretty good at crashing. Doing pretty good at crashing Fusion 360 tonight.
Yeah.
I'm doing it more often than my usual.
Get that
through all day today without crashing it at all, actually. And it doesn't. I haven't found it to be that buggy and to crash that much. There is a relatively new version. They sort of do like about a 1 month release of new versions, but
and that's
this one was not
automatically.
I wouldn't say a major. It was very incremental.
Yeah. But they pushed out automatically. You don't have a choice to not accept it because it's in the cloud, basically.
Correct. Yeah, it's very, very cloud-based, and it's pushed out automatically, and you get a message that says, you know, material downloading is disabled because it's downloading an update, and things like that.
Right.
Okay, let's see if we can not break this. Fact, just as an experiment, it's going to tell us that we were trying to save something. No, there we go. Okay. And we're in inches. We have do we have parameters? We do. Okay, all good. So let's go here and let's create a sketch. And create it on here. I'm going to do something a little different this time just to show some differences. So I'm going to create this this time I put 4 points in my spline polyline, and I'm going to do the same thing here where I force this to be vertical so that it goes in at 90. And I didn't really look at my dimensions here, did I? What's my grid? I probably want it to be a little bigger than this. So I'm going to just pull things out a little more. And the other thing I'm going to do is I'm going to create a line here. And finish my sketch here. And I'll tell you a little bit later why I'm doing that. So I'm going to use now a different approach to creating some of the construction planes, because there's many, many different ways to create construction planes. Plane along a path here at distance 0. There's one plane. I can create another plane along the path, let's say here, proportional at 0.5. And then I'm going to create a plane at an angle. And I'm going to pick this line, and I'm going to make this angle 75 degrees. So now I'm going to sketch on this plane here. And again, I'm just going to sketch my circle, and that's going to be the large diameter. And over on this plane, finish that sketch. I'm going to create another sketch here on this plane. And here I'm going to create a circle. And it's going to be the small diameter. Now, one of the things that's interesting here is that didn't really snap where I wanted it to. So I'm going to use a constraint. I'm going to try and constrain there. So it is forced to be constrained. Finish that sketch. And then I'm going to make another sketch on this surface here. And I'm in fact going to sketch a polygon. And it can be bigger. And I'll say finish sketch. Now I can create my loft. 1, 2, 3, and they must be in order, otherwise it'll either generate something really bad or it'll crash again, which we've had enough of that for tonight. And I'm going to use a center line and select this profile. Center line is not a smooth chain because of the angle at the end. Okay, well, we're not going to use that center line after all. But what we're going to do is we are going to use direction controls at both ends. And here's a sort of funky adapter that goes from being round and round to, for some odd reason, being hexagonal in the middle. And remember that this was at a 75-degree angle. So you see it's at a completely different plane. It's out of plane. Now what I might want to do, if I wanted to make, so I could attach to the hexagonal portion to make any kind of a bracket or mounting features. And I can create an extrusion here, coming out here. And if I want to, I could put taper on it. And I'm going to want this taper to be in this direction so that my hose fits on the outside of that. And so the angle is going to be minus taper. Now join that in. And I could come over here and extrude this guy. And again, I'm going to say minus taper. And I'll make this one 1.5 inches. And if I want to, I can now shell. I want to remove that surface. And I want to also remove this surface. And the inside thickness is going to be my wall thickness. And there I have some kind of weird and probably useless shape that is some kind of vacuum adapter that I can then print on the 3D printer. Anybody have questions about how we went about doing what we did?
I don't necessarily have a question, just curiosity as far as what defines the first plane that you work with, and then the subsequent planes that are offset in the X, Y, and Z, or X, Y, or whatever. How do you determine that, or what's a good reference point to be used?
Well, it depends on your design intent. Like if this were a part that we're fitting into a more complicated piece of machinery, then the constraints would be driven by how it interfaces to other things. If I wanted to mount this to a piece of equipment, then I might add a flange to it somewhere, so how it can be adapted, where I want the various inlets and outlets to be. It all comes down to what my design intent is. This is kind of an oddball one. Obviously, you would usually have a much smaller adapter. I kind of wanted to show a little bit of some of the functionality that you can get. But you can do something as simple. You could do something as simple as having one circle here. And we're back to millimeters. I'm going to just do this quickly to show this, and then let's do another sketch up here. And oh, actually, that wouldn't be good. Let's not do that.
I guess it's kind of like a chicken egg syndrome as far as what is the first thing that you reference off of, because everything else would...
Yeah, for me, it's usually like, what's the easiest point for me to use as my origin? What are the logical, XY plane etc. And I go from there. So then creating extra construction planes is just usually quite useful. So I'm going to create a plane here, off in that direction, maybe not quite that far. Let me look from the front. Yeah, let's bring this guy back. Something like this. Okay, and now I'm going to sketch on this plane, and let me sketch the alternate circle. And this one's going to be quite a bit smaller. I'll finish the sketch. Now, what I might do is create a loft. This circle. Let me drive them direction-wise and direction-wise. And now I have something that's a little more typical.
Got it. Thank you.
Maybe I want to, actually that's something different. I don't want to get into that, but okay. Where my construction planes are here, if I edit this guy, make this 20 into a bigger number, I can play with the net effects on the shape. If for some reason or other I wanted to drive a bolt through there, I can make the hole first and then shell. Now something's going on. That's where this hole started is a bit weird here, and the hole didn't go all the way through. But you see the effect of the different features that you can play around with to get relatively complex geometry. And that's lofts pretty much. Does anybody have further questions about lofts, or is this sort of a little too esoteric and there's other things you'd like to discuss? Does anybody have show and tell?
Well, I think this could be really useful, as you said, with the 3D printer. You can make things without going through your normal geometry, squares and rounds. It's real easy to blend. I think I can see a lot of use for this.
Yeah, I think the 3D printer is probably the key for the kind of geometry that gets done here with a loft. I mean, you can do things that are typically lofted design that come to mind are boat hulls, aircraft wings, aircraft fuselage, elements like that, where you are trying to do a smooth shape that changes for aerodynamic or hydrodynamic reasons. But there's lots of stuff that you can make, fancy little stuff that you can make that lends itself well to the 3D printer.
I actually see a lot of use for this with, once again, hose adapters, which we make a lot of on the 3D printer. But I was attempting to make one that had a 90-degree, it was just an elbow, but it was using exactly your measurements, the 2.5 and 1.5. But I wanted more of the bulk, more of the 2.5 to go down to the corner, because I didn't want to have it too constricted. So
Right.
I played with this weight and direction, I think, to maybe be able to do a better job than what I did on my first design.
Yeah, I mean, there's different ways to do things. The elbow is a classic case, especially if you do something off of 90. Some of the simple lofts that people show you for a demo, really, some of them you can do other ways as well. But to get a good, clean transition, and otherwise minimize the aerodynamic losses inside the airflow or water flow in ducting, piping, or anything like that, it's kind of a neat tool to give those good clean transitions, because any transition that isn't clean gives you turbulence and eats energy and impacts your flow rates.
I'm planning on designing a cabinet that has raised panels, and I can see the use for this in the design of the raised panel.
Yeah, complex raised panel for sure. And there's a lot of simple raised panels you can do with chamfers.
Yeah,
But,
that's where I was headed before.
Yeah, but there's this gives you a lot of freedom to do fairly complex shapes. Now I'm trying to think of a good raised panel you could do with this, and then do it on the CNC.
Yeah, you could do that.
Give you some, you could do some fairly fancy stuff on the CNC with it.
Thank you.
You're welcome. Welcome. Anybody else? Questions, comments, suggestions?
Tim, I'm still just a little bit confused on the use of rails. You use the center line to do that, and I follow along with that, with doing the spline and so forth. But how would you use the rails? I'm not quite following that totally.
That's a good point. Let's do one. So let's actually, we probably can use this guy. Let's just get rid of a few features first. Let's go back to this point, and we're not using a center line here. So let's go back to where we have our sketches. Let's highlight our sketches so we can see them. And let's look from the front. Wait, this is the front. What's going on here? Display. What's going on? Come on. Camera. That's why, perspective. I want orthographic. Somehow it keeps throwing me on perspective. I'm not exactly sure why. I think it's other things I was doing during the day. Okay, so now what I'm going to do is I'm going to create a sketch. I'm thinking on the fly here since I'm going with something I've already got. I'm going to create a sketch on this plane here, supposedly, except it's going to be a 3D sketch. And I'm going to create a spline from point here.
How much longer is yours?
To a point here.
What time is it?
7:43.
And then, wait. Do this again. Line from here to here to here. I'm going to finish this spline. Now, what I can do is select this guy. And insert spline fit points. So I'm going to add a couple of points here. And then what I'm going to do is I'm going to, oops. Why is it not letting me mess that point? Why not letting me play with those points? I'm not exactly sure why what it's doing to me here, but trying to manipulate these points and not being allowed to for some strange reason. I'm not exactly sure what the reason is. But at any rate, actually, whoops, get rid of the whole thing. Let's go back to this sketch. And let's just get rid of the intermediate, the extra points that I put in.
So as you're doing this in a 3D sketch, you're not working on just a single plane, is that correct?
That's correct. So this one is potentially off plane. And I should be able to, or maybe I have to, let me try something here. I haven't done a lot with the 3D splines, but let me try the move function. There we go. That's what I wanted. Okay, and in fact, now I'm going to go back to inserting a spline fit point. I'm going to insert one here, and then I'm going to grab it. I'm going to say move, and I'm going to move it this way. So what I'm trying to do is make very clear that it's 3D. Again, there's no great design intent that I'm demonstrating here. I'm just trying to demonstrate functionality.
So Tim, when you just moved those points, they're actually moving in a plane that's basically the plane of your monitor and not necessarily any of the other planes. Is that right?
No, it's moving. Let's try this again. That's a good question because I zipped through that a little too quickly. So let's grab this point here, and we say move, and it's actually allowing me to move in X, Y, and Z of the origin. So I can move X, Y, and Z. It's not the plane of my monitor. It's the X, Y, Z of the origin.
Okay, so you're moving it along one of those three primary axes then.
Yeah, and I can move it. I can do a combination of the two. I can move it among both. So here you see I have a Y. I can do Y5 and X5. In theory, oh, maybe I can only do one. Each move is sort of individual. So now I have this shape that's really kind of weird. In fact, I think it's going to crash trying to do this. So I'm going to move this guy before. He's just a little too funky. Okay. Now this time, when I create the loft, finish my sketch, create my loft from here to here. Now this time, I'm going to use a guide type rail. I'm going to grab this rail. And now you see the curve, the loft follows that 3D curve that I created. And it looks a little funkier with circles when you have flat surfaces, rectangles, whatever, and you're going along vertex to vertex. Sometimes it makes more sense. It's more likely to fit some kind of realistic design intent, which this isn't. But we can, this direction, this is not going to work because I'm following a rail, right? Yeah. I think. What happens if I try this? Yeah, because I'm on a rail, it does nothing. But that's now driven by one rail. Now, I could also get really funky here, and I'm going to go back into this last sketch. I'm going to grab this guy, and I'm going to create a mirror about come on. It's not the mirror I want. I want to mirror not YZ, YZ. I want to I don't have a mirror line there. So let's cancel the mirror for now, but let's draw a line. And again, the mirror in 3D might be a little challenging. So now let's create the mirror of this object. Come on, select my object. It might not let me mirror 3D. Yeah, it's not letting me mirror that 3D object. It should allow me to mirror it in a plane. There's got to be a way to do this. So let me create a new sketch. And I'm going to grab a sketch plane, even though it's a 3D sketch. I'm going to try to project this. Now let's turn off the body. And let's see if I can create a projection of this guy. And then, okay. Now, can I mirror it? and mirror this guy about, oh, I need to project it as well. Or did I have it there? Hang on. Project this guy. Okay. Let's mirror this about this. Say okay. So now I have another. And that doesn't work because that doesn't touch there. So let's see. So the idea of mirroring was a dead end. So let's delete that one. And let's try just sketching a new 3D sketch. Say on here, and we're going to create fit point spline from here. We're going to come up to out here and then into there. Okay, finish sketch, and we're going to move this sketch before our loft so that when we we can delete this old one. That's not what I wanted. This is the one I wanted to delete. So now this one here, I'm going to edit this feature. And now I'm going to add another rail. That's this rail. And now it's also driving it.
It seems the 3D sketching is difficult, but
it is, and it's a little complicated. You got to kind of figure a few things out with 3D sketching. Rarely do you really need to. You know, we're doing some fairly esoteric shapes here just to kind of go to the extreme. One of the videos that I had put in the forum did a good job of explaining this. It used rails to make finger grips in a sprinkler or a sprayer, hand sprayer pistol grip. And there's one where somebody used a canvas and brought stuff in and did a little bit more of a shape with purpose rather than just an esoteric shape. Speaking of esoteric shapes, if people have good suggestions of, hey, here's a design I'd like to do or like to see you do, I always like those. They're a great, great tool for demonstrating different features, and having a real world application is always good. Travis had one. He couldn't make it tonight for family reasons, but he did send me a photo of something he'd seen on a walk that he liked. And I want to, by the next session, to go through at least one, if not multiple ways to effectively create that. A little bit like we did the cookie tray a couple months ago. And if anybody else has suggestions like that, it's very welcome.
Sounds like a good idea. It actually could be very helpful to some of us too.
Yeah, yeah. If you have something that you're trying to do and you're struggling with it, by all means, send it to me. I'm happy to help out. Just send me an email or reply in the forum or something of that nature.
I wasn't able to attend last week, but I found it very interesting. And when I watched the video, the how you made the plug for Rob.
Yeah, so that's, I like kind of doing the practical things. I'm never quite sure. Sometimes maybe I'm getting a little too carried away with the complex shapes and the esoteric stuff. And I know that, you know, we have people at different levels, but, you know, real world projects are always more fun. And yeah, you show a bunch of little things that you wouldn't see otherwise. One of the things I did want to point out is that in the browser here, you can rename sketches and features and planes. So if the plane has a value, a meaning to you, you know, this could be the, you know, dustbin plane for all I know, you know, whatever it is. And then when you go back to figure out what's going on, it's easier to find those and edit them. So this sketch is, these sketches can be turned off visibility wise. So this is, you know, this is the large D or base or whatever you want to call it, you know. And then later when you come back, you go, oh, I want to change the base. Where is it? Oh yeah, it's right there. You click it in the browser, it highlights down here. Now you can say edit and get the ability to edit this. In this case, we didn't have a dimension on it. So of course, even better is to be parametric and use parameters to drive it. One order of business. So in 2 weeks, I'm actually not going to be around. And so question I have for the group is, would somebody else like to lead the group in 2 weeks? Or would we rather delay that a week? So 2 weeks from now would be the 17th. Delaying it would be the 24th.
I don't feel confident leading it. I really value what you're doing, and I really like the idea of taking on a couple practical projects at that time.
Okay, well, let's make it 3 weeks before the next one, because usually the plan was to do this the first and third Monday of the month, but the first Monday of September is going to be Labor Day, and I'm not sure if anybody, you know, has holiday plans or not, given the current world, but it's probably better to not schedule a session for Labor Day. So if we slide an extra week in before the next one, and then a week in, you know, we'll go maybe move to the 2nd and 4th for September as well, just to kind of take care of the holiday, Labor Day holiday.
Sounds like a plan.
Sound good? And yeah, you know, anybody who has suggestions, projects they'd like me to do, or if you have show and tell, and again, anybody has show and tell tonight, we still have time.
You know, Tim, I think the most valuable things we get is when people do, like requested the plug last week, but if people can actually provide projects that they're trying to work on, that's helpful.
In fact, I think it'd be worthwhile if we had some project suggestions. We shared it with everybody in the group. We did a little stab at it before, so we kind of struggle before we see it with Tim.
Yeah, at one point, you know, somebody had made the suggestion, I'm not sure, it might have been you, Dallas, or it might have been Travis, that we have like a design competition a little bit, maybe once a month. And I like the idea, it's a good idea, but I haven't really come up with any good ones. I'd kind of forgotten about the idea a little bit until I saw what Travis sent me yesterday. And
why don't we take his project and let's make that our competition for it?
Okay, I'll send it out. It's an interesting one. So it's a seahorse that he has seen on his walkabout, and the idea would be to create something that we can then make on the CNC. So maybe I I'll create a forum item for this in the next couple of days, and I'll include the photo of it.
Great.
And then people can start having a look at it, because I'd like nothing more than for 3 or 4 people to make good progress with it in 3 or 4 completely different approaches.
It'll also be the thing that'll test some of our skills and some of the things we've learned. So that'd be good.
Right, right. Good. Anybody have show and tell or other things to talk about? Anybody working on anything interesting with or without Fusion 360?
I'm redrawing the stool they're making in the introduction to woodworking class, and that's been interesting for me. But last week you showed how to explode parts, so you could have a parts diagram and a little parts list, and so I'm using that feature, but it's not really a huge challenge because it's mostly rectilinear.
Okay.
It's been very easy for me to do it in SketchUp, and I'm forcing myself to do it in Fusion.
Well, I know for myself, I had a work project that I had done in Creo that I then redid in Fusion in the early days, back in whenever we started this, February or March, and it was very beneficial for me to force my way to do things the Fusion 360 way. And I think the difference between what the tool I was using was parametric. The difference is perhaps not as great as with SketchUp, but still always good to force you to do something in the new tool.
Yeah, SketchUp is just not the same world at all. But there's so many more features, so much more power by being able to do it in Fusion.
Yeah.
Just the parametric features is all by itself huge advantage.
Mm-hmm. Have a look as well for Lofts. Have a look at the 2 videos that I put in the forum. The Design Online. I always like him. I think he's one of the better ones. And there is a 3rd one that's actually in the blogs, the Autodesk blog that I found later today too. It's something that looks very simple, and yet it's kind of cool. The guy's doing a ring that transitions from circular to rectangular cross section. And there's a few pointers there, so I'm going to post that for people to see as well.
Tim, this is Rob. I did do something in Fusion 360 this last 2 weeks I forgot about, that's pretty handy for showing the parametric change. It's real simple. Let's see if I can call Fusion 360 up. But basically, I had a bunch of loose cardboard boxes and some not even cardboard boxes for my brad nails and my pin nails. And so basically, I took a little bit of a lesson from Paul McWhorter, which we looked at way back when, if you recall, and from what you said about parametric design. And let's see if I can get this responding. And so it made it easy when I put the parameters in for the nail, for the holder for the nails, the boxes, because all I would do is change the width and the length, and it would fit different size brad nails or whatever the nails were. Or I even made one for my desk. Let's see, where's the camera? Oh, I don't have my video on. All right, so for example, here's one on the camera. So this has little USB things inside of it. And it was all using the same file.
This is 3D printed?
Yes, 3D printed. And so I'll pull this one up here now. So can I share my screen?
You should be able to. I changed the setting.
Host disabled, it said. Host disabled screen sharing.
Oh, well, I'm not. Let me.
That's under security.
Yeah, let me see. I'm going to just make you host.
Okay, that's scary. Uh, so here's, I'm going to share the screen. There it is.
And then hit share again.
Share. Okay, can you see the screen now?
There it is. Yes.
All right. So you can see the example. This is just one box of some narrower ones. And then if I just come up here and I say, change the parameters, and I say I want to change the brad size, I change the inside length. Let's say I want to make it for more brads. I put 200 meters. Oh, clicking on my iPad touchpad. That doesn't do any good. And let's say I want to make it, I want to make them wider. So I say 75 millimeters. And I hit OK, and you can see the box instantly changed. And
Yep.
and then I put these little notches in it so that it would be able to, let me hold this up.
Get your
I
finger
found
down.
that they were kind of hard to get off, so I put little notches in it so that I could easily pull them off the top. And you know, at first they were sticking together, so by simply changing, once you got it dialed in, by simply changing these shell thicknesses and lip thicknesses and stuff, you could get the right clearances so that it would come on and off easier or harder, depending on how stiff you wanted to be or how much your printer was calibrated. And then, of course, that makes it convenient because now I can use this same file for any size box I want, because I've got parameters that change the, going over here, I've got parameters that actually change the height, right? The inside bottom height, so I can change the top height. And all I ever do is come in here to this parameter and change it. And my lip height is always, right now, I don't want much to it. So I have the lip height plus 3 millimeters, which means it goes over the lip 3 millimeters, and then it just puts this shell right on top of it. So that's that example of something real useful. I did this in about an hour and a half. For me, you probably could have done it in 15 minutes. But now I made several different boxes, and of course I saved them with different names: nail box medium, nail box large, stuff like that, so it's easier for me. But then I just take and I export this to the if you come over here and you do the 3D print real easy, and I pick this body, this component, I can send it right to my 3D printer and it's all set to go.
Cool.
That's an example.
So you're not exporting the STL file. You're actually running the printer directly from this.
I've done it both ways. It just
Okay.
depends on whether I want to save the STL files for print later. Like if I was going to put a couple of these on Thingiverse, since everybody else has done nice things to give me things. And if I did that, I'd put the STL file up there. But for me, when I'm just printing them on my 3D printer, it's easier just to export it right to my printer and let it go for it.
Yeah, I'm not sure what formats Thingiverse takes, but you could arguably put your Fusion 360 model on there, and then people could make their own size too.
Yeah, exactly. And some people ask for that, but I haven't seen very many people put the Fusion 360 models. Usually they don't put it there. It's the STL file that they put up there, or some other kind of file that's printable by CNC or by 3D printer. Although people will ask, do you have, what did you do this in? Do you have the CAD file, whether it's Fusion 360 or others? I think there's still a lot of people that Fusion 360 isn't as common simply because of its complications, so maybe people don't normally put it up there. But a lot of people do.
Yeah, if you go to GrabCAD, there you'll see people post both sometimes, both STL, or they might include other types of 3D files, and then also the actual native CAD file.
Now, here's a question that I had for the group. So when I do something like this, or somebody else does something similar, which is a pretty simple, straightforward, easy design, obviously I could put it on 3D, Thingiverse or something. I've been thinking I should actually be posting this little project with just a little tiny blurb, a couple sentences about what it does, so that others have access in our community on the San Diego Forum website to this file if they wanted to do it. Saves them an hour or two of developing something else if they wanted to. What does everybody think about that?
Yeah, I think you could put in a form item on the on the woodworkers forum and include a link to the file. I don't know how if you export the file and save it in Dropbox or Box or any of the cloud file services, you can usually post a link to it and then someone can download it from that link.
Yeah, you can do that, but some files, I don't know which one, some files I've posted before, JPEGs and other things, you can actually post right to your posting when you make a post on the forum.
Right, yeah, certainly pictures you can. I'm not sure about putting a CAD file into the forum. I'm not sure what the restrictions are there. Dallas might know.
I'm just wondering if anybody thought it'd be worthwhile, that's all.
For sure. I mean, a little box like that, there's 1,000,001 things you can do with it.
I'm going to turn off the audio now.
Dallas, you're muted. Are you talking?
No, this is Jim. I would be interested, not so much because I want that particular box, but sometime to go back and see just what were the parameters that he linked to each other. So just as a way to see how did he do it. So I would be in favor of that, but I would see how difficult or easy it is to put the CAD file, the Fusion 360 file, how easy it is to put it on the forum. And if it's a whole lot of work to shoot it up to a cloud and then we have to do a bunch of running around to get it, it might not be worth it. But if it can be done easily, I would say go for it.
We've got some guys who are really good with the web. This would be an easy question for Jim McGeehan and Michael would be able to tell us what they can do with that. But I think there'd be other people who'd be interested in getting files like this and maybe some of the adapters and other things that are going up too.
And of course, the things are on Fusion 360 stores on the cloud to begin with, and I've got to dig into how the team functionality works, whether it can really be used to post a little more broadly, or if it's really just designed for a close-knit team like a work team.
Being that it's on the cloud, I would think that you would have a link that you could just post a link and be able to go right to it, and they have a way of sharing it.
That's a good point, Howard, because if you take some of these lessons on the web, the ones you've referenced before,
Yeah.
Tim, sometimes they tell you go to this and you'll get my project file.
Time out. On Fusion 360, go over to the data panel on the right.
Yep.
Go find your file and right click on it. And look at your fourth option.
Yep, share public link.
There's the answer right there. The obvious one.
Well, let me hit share public link, and you'd want it so that they could download and stuff, but you won't want them coming in there and messing with your file. That would be the only thing.
Right.
Allow item to be downloaded. Great. I just clicked on it to see what it said.
Well, and if you share it, you probably have the ability to say they can't change it or whatever, at least, but hopefully they'd be able to share it, change the name, and then they can make it any size they want or so on.
Right. So when you click the share public link, you get the options: share the latest version with anyone using this public link,
Right.
Allow item to be downloaded.
Yep.
If you want, you can require a password.
Right. I just looked at it myself. Yep. That's probably the way to do it. Put that link up there on the
Yep.
form.
And just allow people to download it.
Yep.
Yeah, it's, take advantage of the cloud nature of the tool.
But that is showing what I'm learning is that and that router cabinet I did and the other things lately, because like Dallas said, I've forced myself now to use Fusion because I'm comfortable in
SketchUp.
SketchUp. But the thing is that when it comes to CNC work, what I find myself doing now is I take it from Fusion, I export it to SketchUp, and then SketchUp can export it right into VCarve. so I haven't figured out how to get it going from Fusion straight into VCarve. So
I'm trying to remember what forms VCarve takes, but I think maybe STL is the option because I don't think it takes a step file, does it?
DXF is I always use DXF to get something into the CNC.
DXF might work, Jim, just like you said. The challenge I had the couple times that I tried to do something, it tried to import a 3D model actually into VCarve, and it was harder to mess with because I wasn't that familiar with working with 3D models inside of VCarve. So Aspire actually.
Well, you can. So does VCarve accept SketchUp files directly?
Yep.
Because you can well, actually, I'm not sure because I have the pro version.
Yeah, I export to SketchUp as a SketchUp.
Right.
And then I simply take the SketchUp. I don't even have to open SketchUp if I don't want to.
Right. You just take that in.
I can just open up the SketchUp files. It takes 2019 and earlier files.
Okay.
So you just have to download it. You have to go into SketchUp, save it back as a 2019 file.
Mm-hmm. Mm-hmm.
And then it'll come right into VCarve. And in fact, VCarve will nest your project for you and everything if they're all the same size. Or Aspire, VCarve Pro, either one.
Mm-hmm.
Howard was the one that turned me on to VCarve Pro initially. Then he told me I wasn't a real CNC guy unless I got Aspire. So I had to go buy Aspire.
There you go.
Aspire to be a CNC guy.
There you go.
That's
So
okay. I'm trying to learn Mach 4 right now so I can use the laser function in Mach 4 or Mach 4. So I've been going nuts with that.
Good. Anybody else got anything?
Nothing here.
I don't have anything. I wish everybody a good night. Thanks so much again, Tim, for taking the time to share.
You bet. So we'll see you guys we'll see you in 3 weeks. Meanwhile, you have any projects, please let me know. Fire them to me.
I'm looking forward to Howard getting that laser down and then teaching the rest of us that stuff. Of course, we don't have the laser right now.
Okay, thanks, guys.
Okie doke. Good night, all.
Bye, everybody.
Bye-bye.